Okay, let's go ahead and get started. I'm Charlie Smith, the Executive Director of eSig, and I want to welcome you to our eSig monthly webinar for March. For those of you not familiar with eSig, we're a membership-based nonprofit organization providing our members with objective information, resources, and networking opportunities in support of the energy transition. We do this through workshops, tutorials, webinars, blogs, working group and task force activities, and producing technical resource materials. I also serve in a leadership role with the Global Power System Transformation Consortium, the GPST, whose mission is to bring together key actors to catalyze a rapid, clean energy transition at unprecedented scope and speed. eSig leads Pillar 1 of the 5 pillars, which deals with the research agenda for the system operators. It's hard to believe it's already March, and here we are getting ready for the spring workshop in Tucson next week. I was in Albuquerque last week, and we had a couple inches of snow, but I'm looking forward to a little more moderate weather in Tucson. Daytime highs in the 70s and maybe evenings a little bit cooler. At any rate, I can promise you another great workshop regardless of the weather. Further information, including the final agenda, can be found on our website. Our workshops and monthly webinars are open to everyone, so please feel free to register anytime on the eSig website. If you're new to eSig, I strongly encourage you to follow up with us if you like what you hear, and I think you'll be pleasantly surprised. eSig membership will give you an opportunity to participate actively in all of our working groups and task forces. You can find us on the web at esig.energy, as well as on LinkedIn, Facebook, Twitter, and YouTube. Okay, just a few logistical matters before we get started. First of all, phones will be muted for the duration of the webinar to avoid unnecessary distractions. For the Q&A, we're using the Slido platform. So to ask your questions, please go to slido.com and enter eSig20 as the event code. The instructions are also at the bottom of this screen. You'll see a thumbs up button next to the questions to allow you to cast a vote to help prioritize the questions submitted. We plan to save 10 minutes for the Q&A at the end and then wrap it up at the top of the hour. An email with a link will be provided once the video file has been posted. We also plan to provide short responses to unanswered questions after the webinar, so please don't be afraid to ask your questions through Slido. Today's topic is going to be on AEMO's connection simulation tool. This is a topic of high interest and importance as we look at all of the generations stuck in the interconnection queues around the world. And here to talk with us about it today is Merryn York, Executive General Manager for System Design at AEMO, with several of her colleagues. Merryn is responsible for the industry-wide collaboration efforts necessary to meet the engineering challenges of a net zero energy system in Australia. She joined AEMO just about a year ago and brings deep industry experience in generator connections, transmission planning, regulatory investment, and the delivery of major transmission projects. Most recently, Merryn served as a commissioner at the Australian Energy Market Commission. Previously, she served as chief executive of the transmission service provider PowerLink Queensland. Merryn will lead the webinar today, along with two of her colleagues, and I think we have the right people here with us to talk about this critically important topic. AEMO is a good friend of eSig, and it is my great pleasure to welcome Merryn, Elliot, and Margarita. Today's webinar will address the Connection Simulator Tool, or CST, which is an optional online portal service released by AEMO just last November. It's designed to help developers, OEMs, network operators, and AEMO collaborate using common data sets to quickly verify that prospective generators can be safely connected to the network. It provides users the ability to utilize AEMO's protected wide area PSCAD models to run simulations on a proposed plant interconnection and show the results of the network impacts of that plant as part of the interconnection process. I find this all very exciting and very relevant, and I'm really looking forward to what Merryn and her colleagues have to say. Just a short reminder once again to use Slido at slido.com with the event code of eSig20 to ask your questions. Okay, without any further ado, let's go ahead and get started. Merryn, I'll now turn it over to you.
Thank you so much, Charlie. It's great to be here with you all. And I want to start by acknowledging the traditional owners of the land on which I'm coming from in Australia. That's the and recognise their connection to the country on which we're all meeting. I know that is a focus around the world as we recognise First Nations people in many countries. And good morning to everyone who's here on the seminar. It's quite early in the morning here in Australia, but I know it's different time zones for many different people around the world. We're going to kick off. I've got Margarita Pimentel, who's our Group Manager of Onboarding and Connections, which is the team in our system design area that deals with exactly what Charlie was talking about, that interconnection of new plant to power system. So Margarita is responsible for all of the processes that go from a glint in the developer's eye, working with the developer and OEMs through that connection process, and making sure that they can connect safely and be commissioned on the power system and hand it over to our real-time operations team to keep the lights on. Elliot Kuhlman is also joining us, and he's the real heart and soul of this project. He's been involved in this project from the beginning, when this was a glint in the eye of thinking about how we could help to streamline the process and really involve developers and OEMs, and also NSPs, the network service providers, particularly the transmission companies who do have access to the model, but we do envisage that they may be able to better utilise this tool as well. But really helping developers and OEMs work together to solve their own problems, rather than it being very much a back and forth process with the TNSPs or us in developing those models and making them work in the simulation, let alone on the actual power system. So if we go to the contents slide, Elliot, we're just going to cover a little bit about Australia, the concept and the wide area models that we have developed for the national electricity market, as we call it in Australia, the East Coast system. And then Elliot's really going to show you how this works and give you a bit of a demo. So really looking forward to that. So first up, a little bit about AEMO and the Australian system that we are the market and system operator for. And we're also the national planner for what is referred to there on the slide as the national electricity market. And that's really where my team comes in what we refer to as system design, which is really design of the power system, or that planning function. It's a long, skinny, geographically diverse and quite sparsely populated area. So when we look at the magnitude, yes, Elliot, that next slide is fine. When we look at the magnitude of our power system, in many international standards, it's quite small. So perhaps a 60 gigawatt type system, 60 gigawatts of generation, but it's transitioning very rapidly. So this diagram comes from what we refer to as our integrated system plan, which is a plan that we develop under our national transmission planner function to work out how we can get from where we are to a net zero by 2050 system. So lots and lots of solar and wind to be connected. They're our real resources, and particularly a lot of solar, which brings its own challenges, both utility scale solar that's connected to the main grid, but also a lot of rooftop solar that is connected within consumers' premises, how that's all going to work together. So we are seeing our coal-fired and other thermal generators withdrawing faster and faster, and more announcements come through. We also know that the energy system will be decarbonised through electrification of things like gas and transport, and that is expected to double the amount of energy that will be delivered from the electricity system by 2050 as we work towards net zero. So we're expecting 9 times the amount of utility scale variable renewable energy to connect by 2050. And of course, a lot of that will be inverter-based resources. And that is where that challenge comes in with needing to do those EMT level studies and what has led to the development of our wide area PSCAD model, which Charlie was referring to. So if we jump onto the next slide, we have had a lot of challenges. You're bringing up a lot of media clips where, it really has been a challenge with things seemingly stuck in the connection process or interconnection process between the developer of the new power station and the network and how they can connect. So we are anticipating that pipeline, as we call it, rather than a queue, but a pipeline of developments to continue to grow and continue to be at large scale, and that connecting parties will be in that process for some time. And we have a real focus on trying to make sure that we can streamline that process as much as possible for people by providing transparency about what's involved, but also making sure that they have the best quality of information and access to what they need to be able to self-serve a little more through that process, rather than relying on either us or their network service provider that they're connecting to help them develop their models and make sure it works on the power system. And that's really where the genesis of this connection simulation tool came from. Because the PSCAD models are confidential and they're not able to be shared widely, which is something that we are certainly interested in working through with the range of OEMs that provide these models, how that can be made more accessible. But this is a step in that direction to create this connection simulator tool where we can provide a portal into that wide area model that has been developed. Just to give you a sense of our pipeline, so you can compare it with yours, we currently have about 60 gigawatts of existing generation, so a relatively small system. We've got 9.5 gigawatts that is committed and under development and going through the process between FID on their projects and commissioning and operation on the power system. Another about 6 we refer to as anticipated, where they might have their connection agreement or financing, but they haven't got construction, or they're kind of partway through. And then really our pipeline, 193 gigawatts of potential projects that have been either publicly announced or are in the early stages of that connection process. So we have our own challenges and lots of people and developers really wanting to make sure they know how to get through that process quickly. But I'm going to hand over to the more the technical side of things, because I'm sure you're all very interested in that. And I'll hand over to Elliot, who's going to start to talk through the EMT model assessment, why we need to do it, and how we've made this more accessible. Thanks, Elliot.
Merryn. So I'm not sure how to turn my video on in this presenter mode, but hopefully you can deal without seeing my face through my presentation. So on this slide, so the specific challenges that we've been facing that we wanted to solve with the connection simulator tool, one of the primary things that we've faced is the idea that when someone goes and studies their connecting plant with their new EMT models, at the moment, the way the process has worked prior to the connection simulator tool is that they would study in a SMIB, as I'm sure a lot of you are familiar with. So an approximation of that network, they might find issues, tune that model, come up with a more refined model before they submit that through to AEMO and the NSPs, or the system operators, as I think they may be called where you are. We would then go away, plug those into our confidential wide area PSCAD models, so those big PSCAD models we've been alluding to. If we find issues in that process, so for example, maybe we see an oscillation in the network, the process as it exists would be that we would then send back details of that issue to the prospective plant. They would kind of get a sense of what the problem is and have to take a bit of a guess at a solution to that problem. They'd implement that, potentially send it back to AEMO. We would test, or AEMO and the NSPs, we would test if that solved it. And you can see how that process might become fairly iterative, and it could go on for a while. So with that in mind, let me jump back to where I can move the slides. I'll talk a bit about the connection simulator tool concept. So the general concept is, with the idea of that lack of availability of the confidential models in mind, the system that we've set up at a high level is basically this that we can see here. So there's two servers. One on the left-hand side, the client server, has a copy of the proponent's model on it. And on the right-hand side there's a much larger server, more powerful server that holds our large EMT models and gives an electrical access to those models so that you can simulate directly into the power system. You can see those issues like the oscillation I mentioned pop up, and you can directly tune and fix those issues yourself. So there's a bit more context here about, external user has their own laptop on the very left. There's a web portal that they can connect to, which is a browser application that I'll show you all of in a moment. And then through that web portal, they can connect through to the server, which we'll have a look at as well. That server on the left is fully visible, whereas the server on the right is completely invisible, and that's to keep that confidential information and the make sure that we meet our confidentiality obligations. Although there is some data that goes back and forth to give them a bit more context about how that system is operating when they're running their studies. But with that, I'll hand to Margarita to jump into the next slide.
Everyone. I think Elliot has done a really good job of actually covering the benefits of the connection simulation tool. So I might just very briefly touch on those. Really the emphasis of the tool is around providing the ability for developers to be able to utilize the same tool that AEMO uses. When the developers are preparing their connection application, they can use that same tool that we're going to use to actually assess their application. It allows the developer to gain a more detailed understanding of how the plant actually interacts with the rest of the system, and it means they can identify issues early in the process, and they're all things that Elliot talked us through just before. In the context of that, when a developer can identify those issues early in the process, that means there's less iterations in terms of changes going backwards and forwards between AEMO and the developer. And it also means a lower cost and a lower risk to the developer in the context of unanticipated issues that they might find later in the process that might actually lead to them requiring to install additional equipment. Elliot, I might just ask you to go to the next slide, please. Thanks. In terms of current users of the tool, essentially we've targeted that towards product developers and also equipment manufacturers, as well as the consultants who are actually undertaking the work for those developers. The idea here is that the equipment manufacturers and the consultants will be able to study the plant on behalf of the developers, and also particularly with the equipment manufacturers, they'll be able to pre-screen their models during development as well. We think other users could include network service providers, particularly those who are relatively unpracticed in PSCAD, and also universities for research projects as well. And we might just go to the next slide. Thank you. The project was kicked off. If you look down the bottom at the timeline, the project was kicked off in April 2021. Network service providers actually helped to design how much of the network was available to users. And a lot of that emphasis was around balancing confidentiality of network components or how network components were modeled with the value that could be presented to the user as well in terms of enabling them visibility of the network. You can see there that the minimum viable product was developed in around October 2021 or completed around that time. And trial users were engaged in the process to actually provide feedback on the tool throughout that development process. They also provided suggestions on how the design could be improved. So we actually enhanced the design as part of that process. And we had 3 organisations brought in to actually help us with that process. The tool was launched as a pilot around September 2022, and we had 5 organisations enlisted actually testing that product and once again providing us with suggestions and feedback for how we might be able to improve the tool and make it a more usable tool for users. Full release occurred around the end of November 2022, and then we pretty much entered Christmas, and so So we've had, so the next slide we'll talk a little bit about the interest in the tool and where we're going through there. But it's probably important to note that just throughout that process, we had an industry working group that was engaged throughout the process of development of the tool, and that we try to keep industry updated through industry forums and AEMO newsletters. And apologies, Elliot, because I've probably just confused you with that. So if we can please go to the next slide, that would be great. Thank you. In terms of interest in the tool, it's probably the key thing to pull out from this slide is really the fact that we have 11 users that are set up and ready to go on the tool, and we have two users representing about 1.2 gigawatts of generation that are getting ready to start simulations now. If we go to the next slide, thank you. In terms of challenges that we've experienced in developing this first phase of the tool, probably a key one was around how we could maintain confidentiality of different plant models, particularly to protect manufacturers' intellectual property, but how we could also balance that against providing adequate visibility to developers so that they could understand the interactions of their plant with the rest of the power system. That was a very difficult, it's a very challenging issue to broach in the development of the tool, simply because confidentiality of intellectual property is a very sensitive issue with equipment manufacturers. One thing I will say is in the next phase of enhancements, we're actually looking to provide greater visibility of the network to users, and we'll be working closely with equipment manufacturers around how we do that and how we still maintain that level of confidentiality for them that makes them comfortable. And I think the key thing there is really wanting to enable the users to be able to test for and locate issues, and in order to be able to do that, they really need that visibility of the network, and they need that visibility in order to actually identify the source of those issues and whether that source is actually their generation plant or whether it might be interactions more deeply in the network. Another key challenge was really around how we could build systems that were streamlined and automated to reduce the workload that AEMO actually had to undertake internally. So it's probably important to note that in this first phase of the connection simulator tool, there's still a lot of work that AEMO needs to undertake to actually set up the cases and retrieve the results for the developers themselves. In the next phase of enhancements, what we're looking at doing is looking at reducing that workload and potentially that bottleneck that AEMO might represent in terms of resourcing by enabling users to actually set up cases and retrieve their results independently. We're also looking at how we can provide scripts to enable users to run multiple studies, and also looking at equivalencing parts of the network so that we can actually improve the speed at which those studies can be undertaken as well and reduce the complexity of that work. I think that's probably all from me in the context of just providing you with a bit of an overview of the connection simulator tool. I'm actually going to hand across to Elliot now, who is our guru on the tool, and he's going to just talk you through a demo.
Thanks, Margarita. So jumping into a few more slides first, on the AEMO internal PSCAD model. So just some slides here to give a bit of context. We've talked about this PSCAD model in a lot of forums, and so there's definitely better presentations out there, and I'll point you to one in a moment. But on that PSCAD model, just for some context, where it covers currently, the one that's in the system is all down that kind of west coast or east coast of Australia there. So through Queensland, New South Wales, Victoria, South Australia. Tasmania down the bottom there actually isn't included, but we do have PSCAD models for that separately. On the size of that application, at the moment it's about a 3,500 bus network, as I've written there, various voltage levels, and currently there's in the current iteration of the model, there's 184 asynchronous generator models and SVC models included in those EMT models. So it's quite expansive, quite large, and that for anyone that's familiar with PSCAD, that's encapsulated in 220 individual PSCAD project spaces within a single workspace. So it's an enormous case that covers a lot of area and takes a lot to run. So just to give you a bit of context there. On to the next slide. These are just two features that exist within that PSCAD model that are relevant to things I'll point to in the future. So on the left-hand side, we have a tool for our PSCAD, for our EMT models, that allows us to import an RMS type model into it. So we have very comprehensive systems around our RMS models, and that just allows us to take the load flow conditions or edit the load flow conditions more easily, and kind of load that into the EMT models that we use, our PSCAD models. And on the right-hand side there is the disturbance controller. So this is a module that we set up that just allows you to control disturbances more easily. It's a single port where you can kind of go in, set up multiple faults, select faults from a list, and that will send that through to the wider case. And you'll see the relevance of that once I jump into a few of the demos. So as I said, I'll point to one presentation. This one does exist on YouTube for anyone that's interested. If you do want more context around the EMT models, quite comprehensive presentations have been done in the past by the people who set that up. This one's by a colleague, James Guest, sits on YouTube. I can try to send a link later on, but if you just Google cutting edge technologies towards a net zero world, you should be able to find it if you do want that context. So now a bit of a deep dive into that connection simulator tool itself. So this slide's just to show you a bit about the user process. So this is kind of an overview at a high level of the process a user goes through in interacting with the tool and the systems that we've set up. So just for context, I've put in the top there, you can see how I've defined a case. I'm going to say the word a case a lot. A case is really an instance of a server pair. So an instance of that two server setup where the models have an interaction. So one user might have 10 cases if they want, maybe they have 10 different projects and they're studying all of them. Or maybe they have one project that they want 10 different load flows for. There's all different reasons they could have a case, but a case is one instance of their generator or a generator connected through to our model in some location set up on those servers. So a bit about the user process. On the left, you can see the contract stage. We can ignore that. It's basically just checking that they're a valid user, some legal stuff. Once that's done, they get access to the web portal. So within this web portal, they have a few things they can do, and you'll see that a bit more when I demo it in a moment. But they can set up as many users as they want. They might be a developer who has the admin access, and they want, maybe they have 2 consultancies working for them and 5 people from each. They can add all of those users. All they need is an email. And through that system, they can kind of set up the applications to get a case set up for them. There are a few other systems there on the right that I'll point to in a little more detail in a second. But with that, I can jump into the web portal demo. So I'm going to try to do something insane here and switch over here. Hopefully this is coming through. So this is the web portal. It's really just a browser application. Maybe can I ask, just Margarita or Merryn, can you see this at the moment, just for confirmation?
Yes, we can.
Okay, great, thank you. So this is the web portal. This is just a test system. So this one just sits in the background. This is a portal that many generators use for other things called the SAM portal. So in reality, there'll be some more options here, but for our purposes, they are, once they get access, they'll see this. They have the connection simulator tool module here, and within here, they have a few options. So create cases, edit cases. Create case is kind of an application to get a new case. Edit cases is just to edit those forms, which you'll see in a moment. All cases is a bit more context about all the cases they have going, and then critically active cases is those cases they have set up, or those server pairs, as I mentioned, that they have set up that they can actually get access to. So if I jump to create case, you'll see that it's just a form, pretty basic. So through here, it's basically an application. They're saying, hey, I want to connect. I want a new case set up for myself. Here's all the information I need to provide. A lot of this isn't of too much concern. Some names, a nominated user who we can contact about the project if we have questions. But then of more interest down here, we have type of user. So at the moment, there's connection to NSP. We mentioned NSP might be a future use case. It's built into the system now, but for now, we really only support connection. They also have the ability to select the VM performance level. So they get they get some information that gives them more context about these things, but really it's a trade-off here of how big do you want the machine to be, and so how fast do you want it to run versus the cost that will ensue. We can ignore this one. They also have the ability to upload a model or upload multiple models if they want. Normally it'll be one. But opening this up, they submit, through here they can submit their PSCAD model, some documentation, some legal stuff. And then really from there, it's a lot of information we ask for to get context so that AEMO ourselves can integrate their PSCAD model into our wider model. And so it's all of the questions about that setup. So things like the location, the state, the NSP, which is the operator of that region, key generators they might want included, which we will do a bit of an assessment of ourselves. Special protection schemes, if there are any, network case configuration, so that might be load flow, specific load flow scenarios they're interested in. Intention of use is a bit of a legal one. And then additional information. And in here they might say, I want signals X, Y, and Z, and you'll see how they actually end up seeing that in a moment. But they might ask for additional signals from within the network case, so some more measurements that would give them the context they need, as well as they might maybe ask for additional faults to be set up in the case or something like that. And then just some contact details for someone who can help us out with that model. At this point, they can either save it as a draft or they can continue and submit that through, and that will come to AEMO. If they do save it as a draft, there's an edit cases section over here if it loads. So there's a lot here. Know that this is not real. In their system, they won't have this many. There's a test system, as I mentioned. But through here, they can edit those saved drafts, as well as kind of communicate back and forth with AEMO engineers about whatever it is that they may have filled out incorrectly or may have a question about something. From there, there's all cases. So in this section, they can view all of the cases that they have set up. That might be historical cases that they've already closed. It might be the ones they've saved as drafts. So they've got sections to filter that. But generally here, they can see the cases they have. They can see the ongoing costs that it's accruing, some details about the activation date, etc. So it's really just a holistic view of all of those different cases, historical or otherwise, that they've got in the system. And then finally, they can go to active cases. So this active cases area is basically where they come to finally make that connection through to the system. So this user, as an example, has 3 cases set up. So that's 3 currently running server pairs. And they've got 2 actions here they can connect in, which will open up a browser that has that virtual machine, or they can close it, which will kind of destroy it and stop it accruing costs. But we'll connect through in just a second. But now I'm just going to go back to the presentation slides. So at that point where the case has been submitted to AEMO, we've got all that information about how to integrate. Then AEMO has to move to kind of integrate that into the system, do a few checks in the background, and I'll just talk in a few slides about how that happens. So back to that diagram, you can see this blue section is that AEMO internal systems. So this is that step where we'll go away and create that server. So the first step is to integrate the model. You can see on the left-hand side, I've got PSCAD. So that's basically AEMO is going to take the case, integrate their model into our wide area EMT model. We're also going to do the same thing up the top there into our PSSE or RMS type model. In that one, we'll update the load flow, get conditions to the state that they need, and then kind of merge those cases in a sense. So through that tool that I mentioned previously, load that load flow into the PSCAD case. We might do a few minor tests. We don't want to go too comprehensive or it destroys the point of giving them access to this system. And then once we're kind of done with that and it's set up, we'll upload it into the Git. So I'll explain what the Git is. So for anyone that's used GitHub, it's very similar to that. This is kind of a new and comprehensive system. It's probably one of the major achievements of the tool that exists to help us automate those systems in the background. So in the Git, we basically have our wide area PSCAD model that I described sitting there in the blue, you can see. We might be making changes to that ongoing, maybe where new generators are coming online or network augmentations are happening that we need to update. So that will iteratively in the background get updated. At one point, you can imagine Windy Wind Farm comes along in the purple there, says, hey, we want to use the tool. At that point, we can branch off in the Git, create a branch just for that Windy Wind Farm, integrate their models and do all of that stuff I talked about on the last slide, and then run the pipeline. And so running the pipeline is literally a button click, and it's a big process that we've built, that the IT guys did an amazing job of building, that goes away, creates those two servers, installs all of the required software, the Intel Fortran, all of that stuff, places the models in the right spot, acquires those PSCAD licenses, and then runs some PSCAD automation scripts on the larger confidential master server. As all of that's happening, and it's also sending emails to tell the user that things are happening. And when it's complete, it will send an email and say, hey, your case has been built. It takes about an hour and a half to do that, by the way, just for context. But once that's done, the user will get a notification and it will move into that active cases area that we saw on the web portal so that they can access it. So that's a bit about the internal AEMO systems. After that, they then have access to the real machine. So that's the green here. So now they can go in, they can access their models, they can run studies. And so let me try to show a little bit about what that is. So just here, you can see that it's just a browser instance. It looks a lot like your laptop probably looks, maybe with a cleaner desktop than any of us have. But in this system, you can see that they've got direct access. So it's just a folder structure here. They have direct access to their PSCAD models, just as they provided it to us. If there were parameter files or anything like that, they could edit them. They could delete everything if they wanted to. And when they open that up, they can see that they've just got access to their PSCAD model. So this is a test case, but within here would be their PSCAD model. In here, there's nothing because it's a test case, but normally within here, they'd have that full access to all of their models, all of the detail that they would see if they were working on it themselves. They could change parameters. They could delete the whole model if they wanted and rebuild it from scratch. But basically, they have complete access to their PSCAD models. And then they have an electrical connection that goes off into that other machine that they can't see with our confidential models on it. And this will be that electrical connection. Another thing that they have in here is a results page. So this is where that disturbance controller comes in. They've got access to that. So they can go in here, set up faults. You'll see that there's a long list of faults, and this list will grow over time. But they can select faults they want to apply, put some details about those faults. And when they run up here, that will both run their case and run the large case in the other server and give them that simulation within the real environment. The other thing that we would normally provide in this location is a bunch of results. So we'd give them a lot of signals coming from the network, probably a few buses surrounding them, some key network nodes. So give them voltage, frequency, phase measurements, things like that, just so that they can have a bit of an understanding about what's occurring in the network. And they may request additional signals, as I mentioned, or additional faults. And this is where those would be set up and they could see them. We can ignore this connect name. That's just something to help the scripts on the other side work. But outside of that, the only other things that they have in this system is a plotting tool on the left-hand side here. So that's just so they can plot those results they've already run. And they also have some export features. So this system, as we mentioned, security is our number one concern. And so there's no copy paste features from here. However, they can run this results export. It will take their results, send them to AEMO. And then we can kind of on forward it to them. And the same capability exists for their models as well. So they can get things out of the system if needed through these features. But yeah, generally it's a desktop with their PSCAD installed and an ability to run and connect to the large confidential models in the background. Jumping back, so this is just a So we've talked through a lot, and I apologize if it's overwhelming, but this is just that final view of the whole system. So just to summarize kind of what we just spoke to. On the left-hand side there, we have AEMO and the external user. The external user has access through to that web portal, and that web portal can connect through to the Azure servers that we have set up for them. On the AEMO side, we have an admin access that I didn't show to that web portal, where we can kind of play around as well as make comments on the submissions that they're making. We also obviously have access to our PSCAD models. We can upload them to the GitHub repository, and through that GitHub repository, or not GitHub, Git repository, we can run the pipeline that creates the servers. Through all of these processes, I talked a little bit about it, but there's actually a lot of emails that get sent through the web portal and through running the pipeline, just to tell users where things are at and give them more context about how things are going in the system and where things are at. And the only part additional is on the left, on the right-hand side there, which is AEMO has internal machines and internal systems, and we've tried as well as we could to let those systems directly interact with these CST systems, which just makes it easy for us to, let's say, download a copy of a case, run it on our internal systems and tune it and do some of that work internally. I think that's the extent of the slides that I had. Charlie, I'm happy to move to questions. I do have about 3 more slides I can go through if you want to push to the if you want to push the time a little more.
Yeah, why don't you go ahead? We still have 15 minutes. We've got 20 minutes. We've got a lot of questions, but we'd like to hear the rest of the story for sure.
Sure. So the only other slides, I've got a bunch of slides that some of them maybe will be relevant to questions. So I'll skip through this. There's 4 more slides that I think are worth going through. So one here is the functionality overview. This is a little low level, which is why we kept it out, just in case we did or didn't have time. So the functionality overview, this is just a bit of a picture of how those 2 servers are interacting with each other. So a bit more detail about, we have PSCAD on each machine. There's that electrical connection back and forth. And there's also a dummy electrical connection that goes off and connects to a Python script on the master side. And that's kind of the way that we understand that things are running and things are working. So PSCAD will try to connect. It will end up interacting with a Python script. It'll go, oh, I see you, there you are. And then it can run the automation and make sure the master side's doing things. And then we just have some settings files with IPs to understand so that we can make that connection. And a lot of that information is updated through that pipeline run. And that kind of gives it the context so that it can do the connection and understand who its partner is, if, in a sense. That is the client's master partner or the master's client partner. Additionally, we are starting to think about the future of the tool and some of the enhancements that we'll make. So none of these are guaranteed, but they're the things at the top of our list for future enhancements. So well, here's a slide on the idea that we have future enhancements. So as I said, we did the trial versions, we did the MVP, we did as much as we could. Obviously, we were working to timeframes in that period. And then through November last year, we got to the stage of releasing the final product. I say final. In reality, there were, of course, things that we wanted to do additional that we knew about back then, or things that have come up since through more people using the tool that we know are future enhancements we want to make if we can get the time and budget. Moving into some of those, one of the things that we really want to consider is, so currently on the very right-hand side there, you can see the picture I showed you before of that single generator connecting through to a wider area model. So that's the way that it's set up right now. In the future, we want to investigate the idea of making a lot more of that network available. So really the highly confidential part of these models is the generator models that sit on that master side. And so of course we would never give access to those, but there's a lot of potential to potentially move to one of these X-marked scenarios where we give network access. And if we do that, that allows people to create their own measurements in the system. It allows people to set up their own faults in the system, and that kind of takes away some of the burden on the AEMO side, as well as saves cost, because that AEMO side, we do recover. This whole thing's a recovery-based mechanism. So if we can move work away from the engineers in AEMO, then it's less that we have to charge back for use of the tool. Another part is improve run automation. So at the moment, Margarita alluded to this. It's at the moment a single run, so it's manually run. You go into that system I showed you, you click run, wait for the results, come back, click run again. A big piece of feedback is that people want that automation on the client side. So there was some concern around the security of adding Python on that client side, but whether it's this specific solution I'm showing here or whether it's another way that we do it, we want to give a bit of run automation on that client side. So allow someone to set up a bunch of studies and run them sequentially. And then lastly, the idea of network equivalency. So this is that picture of the PSCAD model. It's an incredibly, incredibly complex thing that takes a lot of server power to run. And so the idea here being, imagine that you might be studying in Queensland in that yellow section up the top there. You can see that we've got quite a long network. Model in South Australia in the bottom left there may not be necessary or may not really impact the studies whatsoever. And so if we can equivalence parts of the networks out and we can make an automated system that does that easily, then that could save a lot on the computing power required and thus save cost for people in the end, as well as improve the runtime. So a double benefit there. And I think that's the last slide that I cared to go through. I can jump back here. Charlie, you mentioned there's a lot of questions. I'm happy to jump into those.
A lot of questions. Yep. I would say this is one of our highest question-related webinars. Before we jump into them, and just a quick question from me. I'm curious. Have you seen any improvement in the time required to get through the interconnection study process, or is it still a little too early to tell? What's your experience and expectation on that?
Yeah, I mean, I'm happy to field that one, but yeah, I think as you said, it's a little early to tell. We haven't had anyone that's gone through use of the tool and then come out the other end in a sense. So put it up, started using it, and then stopped using it. And so that's the kind of feedback I'm sure we'll seek once people have. But the feedback that we received through the working groups and through the trial users, really that was a big part of their thinking behind the access to the system. So we expect that it should. The other part is de-risk. So as well as necessarily reducing time, a lot of people talked about risk and just saying, maybe our system would have been fine, but the idea that we can test it more and make sure that there won't be major issues makes us, feel a lot better about going into that system. And ultimately that if they avoid that, it is saving time, but for a lot of people, it's a question of risk.
Okay. A lot of the questions were submitted in the first half hour of the presentation, Elliot, and some of them I think you've answered either directly or indirectly, but we'll just go through them, and if you feel like it's already been explained, just say so or give a quick response. So the first question that's risen to the top here is, do the projects have to be in a queue to run the simulation? And how often does AEMO's network need to be updated to run the simulation?
So they don't have to be in a queue in a sense. I assume that question, they're imagining that it's kind of like submit your model, we'll get to it. There's more a queue in the sense that at the moment there's no real limitation to the number of individual cases, as I mentioned, so server pairs that we can have. It can go infinitely, apart from the fact that there's an engineering effort associated on the AEMO side. So there's some work we have to put in, as well as we have to purchase PSCAD licenses. So the PSCAD licenses are provided in this system, and we have to make sure we have enough. So the only limiting factors are those. Yeah, they can be alleviated in different ways, but really the only sense of a queue that exists would be that if there's too many people trying to come into the system, and we don't have either the capacity or yet have the licenses, but that would justify buying more. In terms of them running the simulations though, once they've got access, once they're in, they just have that server sitting there and they can use it as much as they want. They can run as much as they want. They can not run as much as they want. And they have that complete freedom until they close the case themselves.
Okay.
Sorry, Charlie, just to expand on that a little bit in the way in which this fits with the actual regulated connection process or interconnection process. It's not compulsory to use this connection simulation tool. This is an option that's available for connecting parties, which they pay for, basically. So this has been developed, and I was remiss not to say that this whole connection simulation tool project has been supported by the ARENA, the Australian Renewable Energy Agency, which is has a grant system provided by the Australian Commonwealth Government, so the federal government of Australia, and they made a contribution to the cost of developing this tool, which sits on the side of the connection process. So people could go through the connection process, developers could go through the connection process with never using this tool. But this tool is available on a fee-for-service basis, such that we are hoping that people who use this will de-risk, to the point Elliot made before, but also speed up their process, be able to use less of our resources, which they also pay for in the connection process, such that they can have more transparency, more speed, lower cost through that connection process. So it's not free, it's not compulsory, it's an option that they have to use this tool with the aim of speeding up and de-risking and lowering the cost of their connection process. I hope that provides a little bit more context.
Sounds like an option worth pursuing.
We hope so.
Okay. The next question here is, can the connection simulation tool support clusters of projects, or is it only a method for sequential studying? In the US, sometimes to speed up the process, we do cluster studies with multiple projects at a time.
So in a sense, yes. There's one user that will have access, and so obviously people are submitting confidential PSCAD models. They don't want other people to have that access. But we set the studies up in a sense to the level that we would set them up if we were doing the study internally. And so for us, we have committed projects that are not yet operational but are past the threshold of knowing that they will be. And so those projects will all be added and included. However, there is a pre-committed phase. It's not necessarily a direct guarantee that we'll cluster projects in the sense that it will include other projects near them if they're not at that committed phase yet. However, if an individual generator, let's say, had 3 connections that they were pursuing themselves in a local area, they could submit all 3 models and ask us to integrate all 3. There'd be a cost associated with that, but we can do it in that sense. So there'll be a lot of setup, and we try to set it up to reflect exactly what we would study internally if we were doing the project in our own connection process.
And
Okay,
it's probably worth noting, Elliot, that because you can actually include anticipated projects, there is that ability to assess clusters of projects. It's just a question about who coordinates that and how that happens within the tool itself. And we are actually thinking about how we can adopt a clustered approach to assessment of projects to be able to expedite future connection processes and enable that ability to look at the interactions between different proposed plants as well. And that's probably something that we'll look at in the context of the next phase of the simulation tool.
Okay, I think it's something we'll look at in the next question as well, from Dave Mueller at Internex. How are other existing IBR units represented in the network model? Does this allow for evaluation of controls interactions possibilities?
So they're basically, as I mentioned, we'll provide them in the level of detail that we have. So in all likelihood, there'll be an EMT representation of nearby IBR plant that's relevant. where they've passed that committed threshold. In terms of control interaction, we are limited in what we can provide to meet our confidentiality obligations in terms of we can't let you see into the controls of another plant. And we have to kind of limit a bit of what we can, a bit of what's visible in that plant, given it's an EMT confidential model. But there should be enough context that you can get an idea that those control interactions have arisen. You should be able to understand if your plant is necessarily to blame or not. But in terms of knowing for sure, I would say that it's kind of, it's limited, but it's very possible within the system.
Okay. Next question. What are the criteria for including the projects in flight in the system model? Sure.
When we say in flight,
yeah, projects in flight, projects in progress.
So I mean the past that committed threshold that I mentioned, and maybe I should define it. So as I say, committed is essentially through our connection process, we get to a stage where there's certain agreements that trigger the idea that they're committed, the idea that they're much more likely to go through and continue that process. And so for those plant, the process is that when it's submitted to AEMO, the application, we'll make an assessment engineering-wise of what should be considered, the same assessment we would make internally if we were studying it ourselves, and then we will integrate those models. In all likelihood, we actually have a PSCAD case that we keep up to date with those committed projects. So in all likelihood, it actually will already be there ready to go, and we'll just integrate their model. But as we say, in terms of those plant pre that phase, it can be a bit more complicated, but there are ways in which we can orchestrate that.
I think in terms of the criteria, Charlie, it's also making sure that the project is real. So you don't want to, it's not the proposed projects where it's very early stages. So things that we will look at is, you know, do they have land to build their project on? Do they have land planning approval such that they can construct their project from an environmental point of view? Do they have a connection agreement with the network service provider and clarity around how they're going to be connected into the power system? Do they have the financing? So have they reached financial close? And do they have a construction contract such that they can actually build their project? So there's a range of criteria to make sure that we're not putting a lot of projects in our model that aren't going to turn up. We want to make sure that the projects are well progressed and have a fairly high degree of likelihood of progressing through to actually construction and commissioning onto the system. So I hope that provides a little bit more context.
Yeah, don't want that 190 gigawatts in the model. For sure. Okay, for network studies, how do you stress the system or handle different load levels?
So at the moment within the tool, there's essentially, to start with, there's one real operating condition that we typically start with, which is a low load stress scenario, low synchronous generation. We allow some ability for people to request changes to that load flow and request different scenarios. However, that's got workload associated with it. In the future, we want to build a few more scenarios. And so what we would be doing is creating from our RMS case, maybe a handful of load flow scenarios that we let someone choose from, and all of those they would all be with the aim of creating stress scenarios. So the only additional note there is that when we integrate the projects, we'll make assessments to try to keep generation locally at higher output. So generation plant that they might be likely to interact with and things like that will be assessed in the local area. We'll do a bit of an assessment of that local load flow internally ourselves as AEMO, and then provide that to them directly. So it's relatively limited, but we make sure the case that we give them is a stress scenario, and that's to reflect what we would study if we were going to be doing this internally ourselves.
Okay, I want to make sure we get to this next question here, so I'm going to go ahead and ask it from Bill Yancey at Electric Power Engineers. I think a lot of people will find this interesting. What recommendations or lessons learned would you pass along to any ISOs who may be thinking of implementing something similar?
Oh, I've been
A
involved in
hot
the
topic
process
in the
for-
US right now, for sure.
Yeah, I've been involved in the process for a very, very, very long time. Look, I think something that really helped was setting up a beta. So we really, before it was in any sense a formal project, we set up, there was like three of us, three engineers just set up, let's set up some basic scripts, a basic model, prove that it works, and make sure that the concept itself, I think creating kind of in terms of just the functionality, creating something that works fairly robustly at that stage can be very helpful. Those scripts are still in the system in a large sense, have been updated, but a lot of that basic work we did at that very beta stage has remained within the system. I think as well, there's a big piece around, at least for us, and I assume confidentiality will be the same concern, around the platforms and getting the architecture guys, the IT guys involved earlier and letting them create a more comprehensive plan of how the system's going to work earlier would have helped for sure. 'Cause that was probably the most time consuming part of the whole project, was setting up the IT systems and getting those systems working to a good degree. Yeah.
So
hopefully
Charlie, I think the key would be come talk to us. Don't reinvent the wheel. Come
Well,
talk
thank
to
you for
us.
that invitation.
We're more than happy to share and leverage what we've done to help others, because we know that's the only way the transition's going to get done worldwide. So yeah, just come talk to us.
I appreciate that. That's very kind offer. We're running just a little late, but there's one more question here I'd really like to ask. Maybe you have a quick answer for it. Have you had an opportunity to verify the simulator tool with a traditional connection study, or are the connection studies no longer required?
So the connection study, I think I'm answering this question. The connection studies are all exactly the same. Nothing's changed about the connection process. So everyone still goes through the same process, even if they use the tool. So in a sense, they're all still the traditional connection process, if that makes sense.
Okay.
But we
Just
should get a better
hopefully-
quality model. We should get
Yes.
better quality input into that process. So the work that we then have to do should be of high quality. But we haven't had anybody go through the full process as yet. So that's a bit of a work in progress.
Okay. Oh, keep us posted.
Absolutely.
Okay, we're just a little past the top of the hour, so we're going to need to wrap it up. I want to thank Merryn, Elliot, and Margarita for this really fascinating webinar and for these great insights, which I hope can give all of us some ideas on how to speed up the interconnection process. It's quite a worthy goal. As I mentioned earlier, an email will go out once the video file has been posted, and we'll answer the questions we didn't get to and get them posted as quickly as possible, subject to the agreement of Merryn, Elliot, and Margarita. Everyone, we appreciate your engagement. We look forward to seeing you again soon. We have more webinars coming up in April, and of course, our spring workshop in Tucson next week. Further information on all of the webinars and meetings can be found on our website at esig.energy under events and in our newsletters and informational emails, and you're all invited to attend. Merryn, Elliot, and Margarita, thank you once again for this very timely and informative webinar, and thank all of you for your interest. We look forward to seeing you again in the near future. And in the meantime, everyone, take care, stay safe, and thanks for your participation. See you soon.
Bye, everyone.
Everyone.
Thanks, everyone.